Hello, tonight we are going to be talking about the atom and the electrons and how they fill an atom. This is kind of what you learned in physical science.
It's called the planetary model, that the electrons are going around the nucleus constantly in one consistent pattern, circle pattern. But that's not right.
No. In fact, your physical science teacher lied to you, telling you that they filled in these big circle orbitals, and that was disproven in the early 1900s after Bohr made his discovery and mathematical equations started being put to it, which we talked about in our last unit. Okay, so this is what an atom really looks like. The nucleus is very small. When we draw an atom, we don't even consider the nucleus there. And we draw shapes in which the electrons follow. And so we are going to learn how to do that today. So to understand this, there's a set of quantum numbers, and there are 4 main numbers.
The first number is going to be the principal number, and it's the outermost shell of an atom, which is equal to the period number. Remember, periods are going to go horizontal, so that's going to be 1 through 7.
So right down here, so these are going to be our
periods
and our quantum number.
Yep, our first quantum number.
Okay.
And then our second quantum number is the orbital number, and that is the shape of the orbital that has valence electrons, which are the same as their block letters. So we have our S, P, D, and F.
Weird. It feels like we've done these before. Oh, maybe with our quizzes. D and F. So the blocks here. Now we're going to be using this with our period numbers to describe where electrons are being placed in an atom.
Next is our magnet number, which tells us the axes that the valence electrons are in. It's going to be either X, Y, or Z.
Yeah, and so when we're drawing these, they're actually going to go on an XYZ axis.
So hopefully you know what those are. X is the horizontal, Y is the vertical, and Z is going to be the diagonal one. And then our last one is the spin number, and that's going to tell us which direction the electron is spinning in. It's either going to be represented by an up arrow or a down arrow, or it can be represented by +1/2 or -1/2 of the spin. And when I like to think of quantum numbers, I like to think of the telephone number. So last 4 digits of your telephone number. The first ones can be the same. The last 4 digits is going to connect you to that certain person that you're trying to call.
Right, so these are all going to be numbers that we can use in different kinds of diagrams. And there's actually 3 ways that you can show how electrons fill an atom. And we can actually draw out the atomic orbitals using the X, Y, and Z axis. Okay, and we're going to go over all of the different shapes and such. And then you can do electron configuration, which is, quote unquote, I've seen it many times, called the sentence form. And there you're just basically writing out the quantum number, the principal number, what's the second one? I forgot already.
Oh, the orbital number?
Orbital number,
or letter.
And then the number of electrons that is occupying that space. And then the Aufbau diagram is like a chart. And this chart is really what it is used for, is so that we can see that spin number. And the spin number is illustrated in this Aufbau diagram really well. So we're going to learn about each one of these. Each one of these will be something that you'll be tested on. And really you could use one atom and draw all 3 of them. Okay, so the first one is atomic orbitals. Obviously there are 4 different orbitals that match up with our 4 different blocks of the periodic table. And that's one reason we separated our periodic quizzes into that. So an s orbital is going to be everything in the s block is going to start out with this shape. And this shape is a sphere. So that one's rough stuff.
Pretty easy.
Yeah. And these spheres can only hold 2 electrons only. Okay, so in the past we said the first orbital could only hold 2, and then they could hold 8, 8, 8, and 8, 8, 8. That's not true. Okay, it's a s orbital and a p orbital that hold the 8, and this s orbital, all s orbitals can only hold 2. The total number of groups in the block, so what I'm referring to here is the amount of groups in the block. So in the s block there's group 1 and there's group 2. So we have 2 groups in this block, and so the s orbital is only going to be able to hold 2 electrons because there's only 2. And then there's only one sublevel, which I'll explain that more when we get into the Aufbau diagram. And again, there's only 2 electrons. Okay, p orbitals are going to be dumbbells, and there's actually 3 sets of p orbitals. And p orbital is the one that deals with the x, y, and the z axis. So we have an x dumbbell, a y dumbbell, and a z dumbbell coming out at you.
And those x, y, and z's follows the axes, so don't get confused. Okay, so we're just drawing them how they would follow the axes.
Right, so that's on the x-axis, the y-axis, and the z-axis. Okay, this entire p orbital set can hold 6, but again, each suborbital, this would be considered one suborbital, which is the x p orbital. This is a suborbital, is y p orbital. And then this is a suborbital, which is the z suborbital. And each of them can only hold 2. Okay, so you can have 2 electrons that go into this one, 2 electrons into this one, 2 electrons go into this one, and this gives you a total of 6. Now this number matches perfectly with the numbers in the group because there are 6 groups. There are 1, 2, 3, 4, 5, 6 groups in the p block, meaning it can hold 6 electrons. Okay, and then the d orbital holds 10, and these get a little bit more difficult. We won't be drawing these 2. We will be drawing atoms that are in the s and the p orbitals. The d orbital is a clover, and there are many, but the clover just looks like this. And there's one that can go on the x-axis, one on the y, one on the z. Each of these clovers can only hold 2 electrons, just like the suborbitals of p. Okay, but there are, instead of having 3 dumbbells, there are 5 that can, 5 different suborbitals that all hold 2, giving us a total of 10 electrons per shell. And that's because there are 10 groups, and you guessed it, hopefully. There are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 groups in the d block. And then the f orbital is a flower clover, and this guy just has one coming out at you, one behind. He's nice and cute and very confusing to draw. He holds 14 electrons total. You guessed it, because there are 14. I'm not going to count them, but there are 14 in the f block. 7 total flowers. Each of those flowers hold 2 electrons. So as you can see, it would get pretty confusing to draw on there, but we are going to try to draw one. So let's go ahead and, what element do you want to draw, Miss Aarons?
Let's do phosphorus.
Phosphorus. Very good. Phosphorus is number
50. Atomic number is
15. Okay, so what we're going to do is we're going to start out, and if we look at our periodic table, you're going to see that the first very element that we can look at is hydrogen. Okay, so this is in the S block, so we're going to start out with a circle, a sphere. And we're going to start out with 1 electron, which will be hydrogen. So we come here, we draw 1 circle. We draw 1 dot on it, that's hydrogen. Okay? as you move across to the next one, now we're still in the first energy level here, and technically this can be over here because it has 2 electrons. So to draw helium, we're just going to put one more dot. So if I asked you to draw helium, it would look really similar to what your physical science teacher had taught you. All right, now the next one for 3 electrons gives us lithium. Now we need our second shell. Now we're in the second energy level. And S block, so that means an S orbital.
So that means it's going to be a sphere again, and it's going to be a little bit bigger.
Switch colors here. So I'm going to do second energy level like this.
So then we have 1 electron for lithium, and then if you move over, we have the other electron for beryllium.
So this is beryllium. Still looking really similar to that model that our physical science teacher showed us. Okay, but now this is where it gets different. So now we travel across, and we get to here. Now we are in the P block. Still in the second energy level, except for now we're going to have 5 electrons, and we need it to be P-shaped. So our first one that we always use is on the x-axis. And so on the x-axis, I am going to draw inside the second energy level a suborbital, like that. Okay. Then the next one is going to be on the y-axis, right here. And so we'll draw another dumbbell inside the second energy level, and we get carbon. That's what carbon looks like. Okay. Oops. And then our next one is on the Z. Now we're only to nitrogen. And so we draw
our Z in the second. There we go. At electron. Now we're at nitrogen.
And notice I've made a new orbital for each of the first 3 electrons. We're going to explain that more here in a second. But now these 3, off the last 3, can be the second electron of each on each of these suborbitals. So we have oxygen goes here on our x-axis, fluorine goes on the y,
and then
neon goes on the z-axis. Now these dots could go anywhere.
Remember, because we don't know the exact velocity or position, we either know one or the other.
I just know that this electron is traveling somewhere along
that orbital.
This suborbital.
Yep.
Yep. So this is neon. So now we need another energy level. Go blue. Okay, so now we're back at the S block. And we are right here, so we have the third shell. First one, S orbital. So we're going to have 2 electrons on it.
So the first electron was sodium, the second one was magnesium. And then we're going to go across again.
And so our first suborbital is always
on the x-axis.
X-axis. So we're going to go all the way out here to now our third.
And that's going to take care of aluminum.
There's aluminum. Now we go Y.
And that's going to take care of silicon. And then our last one's on the Z orbital, and that's going to be where phosphorus is at.
And this is phosphorus. So that means that each of the third level P suborbitals only have 1 electron.
Yep.
And so this would be considered our valence electrons.
Exactly.
And these orbitals having shape like this is going to give rise to the shapes that molecules have and the way that they bond. So if they were all just big circles, we wouldn't have any shape to anything. So when you get into covalent bonding, we're going to talk about these again, so don't forget this information. Alrighty, so that's drawing phosphorus. We'll absolutely do another one in class. Alright, electron configuration. Same exact thing,
Yep.
except for now we're writing it as a sentence.
Exactly.
So let's go ahead and pick a different example for this one. Or maybe we should do phosphorus again.
I say we do phosphorus. We'll keep it the same.
Let's do
So
phosphorus
we can
again.
compare them.
Okay. Phosphorus again, 15 electrons. This whole chapter is about electrons, so we write 15 right now. It's only dealing with electrons. So this is where we're going to use those principal numbers. So if we look at our periodic table here, our first principal number is 1.
That's going to be our period.
And then our orbital number.
Yep, it's going to be the letter that our orbital, whatever orbital was in. So we're going to start off with S. That's where we're starting with hydrogen.
And then we write the number of electrons. So if we're going to write the electron configuration of hydrogen, it would just be 1s1. And the electron becomes like an exponent to the orbital. So if we're going to do helium, it would be, just kidding, 1s2. Okay, so we're going to go to phosphorus right now. I might just do it on this page. Okay. For just the fact that we don't have to flip back and forth. Alrighty, so here we go. So hydrogen is going to be 1s. Now, since we don't want to stop at hydrogen, we want to fill this entire suborbital, which would be the s orbitals can hold 2. And then after you get there, just like you're reading a book, you go to this level.
We'll start with that second one. So it's going to be 2. We're still in the S block. And we have 2 electrons there to take us to beryllium. And then we're going to travel across. Still in the second energy level. But we're now in the P block. And we have 6 there.
We get 1,
1, 2, 3, 4, 5, and 6.
Okay.
Then we keep reading and we're going down to the third energy level, and that's going to take us to 3, and we're still in the S block, so that's going to be 3s2 to drive us all the way across. Over.
So what's this element right here?
Oh, we have to skip those.
Well, if we were just going to stop, what element would this be? Anybody know? We're in 3s, and there's 2 electrons. This would be magnesium. We're not stopping there. Now we go still
3.
3.
So in the third energy level, we're in the P block. And how many electrons do we have to get to phosphorus? We have 1, 2, 3.
Phosphorus. Electron configuration.
Yep.
Awesome. We might do another example that goes into the D block. What do you say?
Can I say we do?
D block, this is where D block gets a little sticky, and this is why we didn't talk about valence electrons. There's just all of this information. So let's do
a hard one.
Do silver? That's what I was thinking.
There you go.
Perfect. Okay, so you're still gonna have to do the beginning. So you're gonna have to do 1s1,
2s2, 2p6.
They're all gonna start like that.
3p.
Oh, I could have just left that, I suppose.
That's okay.
Okay, so we'll start over. So we're gonna do 1s2,
2s2, 2p6, which takes us all the way to neon. 3s2, which is magnesium. So we're going to go all the way across. 3p6 to argon. Then we're jumping down to 4s2. And this is where it gets tricky.
Uh-oh. We're hitting the D block.
We hit the D block.
D block always means trouble.
Trouble.
Alright, so when you hit the D block, there's so many electrons in our little picture, whoops, in this one, that what happens is, because of those clovers and those flowers from the F and the D block, those electrons become so attracted to the nucleus, because there's so many of them, they drop down an energy level. So that means that here you always start with 3d, when you get to the D block. This one will be 4D, and it's always one less than your principal quantum number.
Yep.
Okay, so this row here is going to be 5D, and this row will be 6D. So after 4S always comes 3D. And then there are
electrons out of there. There's going to be 10.
10. And that's why we don't draw these.
Mm-hmm.
Okay, and then after you get through the D block, it
Then
goes
you go
back
back
to
to
the fourth. So this is 4P here. So 4P1 would be gallium. But we're going to continue. So 4P6 takes us over here. Now we go down. Now we're here.
And it's going to be 5S. 2. And then we're going to the 4D because remember we have to go, there's so many electrons it drops down in energy level. So 4D, and then we can count over, and there's 9 to silver.
9 to silver. Perfect. So you can kind of see we're using the periodic table as a map. Literally, we follow what we've learned about it in the last chapter to draw these electrons filling.
And just a little key there too, if you take those exponents and add them all together, you should get 47 because it should be the same number.
That's correct. So, yep, so these exponents up here, each one of them as we go across, you add those up, there should be the exact number of electrons. Okay, and then what if, Miss Aarons, we go to maybe like
We're going
tungsten.
To the F block? Oh, okay, we can go to tungsten.
So I'll just continue on from where we were.
So we were at silver for 4D9, so we're going to go through that to cadmium here. So that's going to be 4D10. Then we are going to go through 5P6.
You like how I use that P?
Yeah, nifty.
Okay.
Then we are going to go to 6.
Now we're in the S block again.
Yep.
And there's 2 electrons, takes us to barium. Alright, now, as you can see, this 57 through 70 is supposed to be up here. And so this periodic table is supposed to be way more spread out. So when you hit this, we actually go to the F block before we get to the D block.
Yep.
So this is going to drop down 2 energy levels because they're so big. So this is 4F.
And that is
5F. So this is going to turn into 6S2, and then
4F. And then how many do we have in the F block? We have 14, so 14 spots there, 14 electrons. And then we're going to go back up to 5D.
5D.
And it's going to take us all the way, what we're going to?
Tungsten.
Okay,
My favorite.
so W. So we have 1, 2, 3, 4.
5D4.
Yep.
Okay. And that is electron configuration. There is also another way we can do this. It's called noble gas notation,
which is a lot easier. So let's use tungsten again so they can see how much it cuts out, how much work it cuts out.
Okay, so we're going to do tungsten again right here. Except for this time we're going to be using noble gas notation, and we'll ask you to do both of these on the test.
You can think of noble gas notation as a shortcut.
Yep, and so we'll see if you can write out the whole thing, and then we'll give you a couple long ones that have noble gas notation. And literally you're just using
the noble gas. So noble gases are found in group 18. And you always go to the noble gas that comes before tungsten. So if you start off at 74, you're going to travel back up to 39.
Alright, so all you have to do is you put the noble gas in brackets, and you start from there. So basically this right here encompasses all of that. That's the same thing. This and that are the same thing.
They're equal to each other.
That's right. So we would start off with the next one after
the noble gas, which would be 6S2.
6S2, and then 4F14,
and 5D4.
5D4 takes us to tungsten.
Noble gas notation.
Voila. Okay, but funny thing here is the number of valence electrons is the outermost shell. So what's the outermost shell in this case? 4, 5, or 6? It would be 6. So we have 2 valence electrons, even though this one is not full. So remember the outermost shell, that's why the D block, we can't use the group numbers to tell us valence electrons. Alrighty, so that's electron configuration. And the Aufbau diagram is our last one. So we have kind of 3 rules that go along with this.
Yep, the first one is the Aufbau principle, and that is an electron occupies the lowest energy level, lowest energy orbital that it can receive. So it's going to start off at the lowest energy first, and then we're going to increase those energy levels.
So it's always going to start off with 1s.
Yep, always.
And then it's going to go to 2s, and then 3s. Okay?
The next one is going to be the Pauli excursion principle, and that says no 2 electrons in the same atom can have the same set of quantum numbers, which we talked about those 4 quantum numbers being like the telephone number. None of them are going to be the same, and mostly what differs with each electron is going to be the spin. So,
and this just says that you can't have, for this chart, we're going to have boxes, and electrons are going to be represented with arrows, and up and down arrows, indicating the up and down spin. And so you would never have 2 up arrows. That's what this is saying.
Or never have 2 down arrows.
Or 2 down arrows would be frowned upon. Or it just wouldn't exist, actually. And so the only thing that you can have once you have 2 arrows or 2 electrons in the suborbitals is 1 up and 1 down.
Yep, and those arrows are representing the electrons.
Yep, these are electrons. Alright, then our last rule
is Hund's rule, and that says orbitals of equal energy will only get 1 electron until every energy level receives 1. So they have to each have 1 electron before they get this pair. And they want to have a pair because that means they're happy. So,
okay, so like the P, the suborbitals, they have the X and the Y and the Z P orbitals, remember? So we have the suborbitals each holding 2. So what that means is you can't give X 1 and then 2, just like we didn't draw 2 dots on the X suborbital when we were drawing the atomic orbital. We put 1 in the X, and then we put 1 in the Y, and then we put 1 in the Z, and that was because of that.
Yep, and then we went back and gave them their pairs.
So you're always going to give 1 up, and up always goes first, and then up, and then after all the energy level has 1, then you'll go down and give the down arrows. Alright, let's do an example. Okie dokie. So, phosphorus, how about that?
Okay.
We'll do it on this page, and we'll say, just kidding, not electron configuration. Aufbau. Okay, so we're going to start at the lowest energy level,
which would be 1s.
And boxes are indicating suborbitals. So this used to be a sphere, right? Or it is in the orbital. But now it's a box. And it gets
2 electrons.
With opposite spin.
Yep. 1 for hydrogen, 1 for helium, and then we can move up to the next orbital, which is going to be 2s. And that one gets 1 box as well, and it's going to have lithium and beryllium.
So this would be beryllium's Aufbau diagram.
That would be beryllium's Aufbau diagram.
Okay.
Then we're going to jump across to the 2p, and we have 2px, 2py, and 2pz, so it gets 3 boxes to show those suborbitals.
And this is what we were referring to here, saying that there were 3 dumbbells. Now we are doing boxes. So then there's going to be 5 clovers or 5 boxes in the Aufbau, or 7 boxes or 7 flowers in this one. So here we have
boron, and then we have to go to the Y,
okay,
which is carbon, and then nitrogen in the Z, and then we go back and give X its pair, which would be oxygen, then fluorine, then neon.
Okay. After 2p, you use your periodic table, go down next level.
3s.
The same exact thing.
Same exact thing.
Using the periodic the same exact way when we drew it, when we did electron configuration, and now when we're doing this one. So S is just going to be 1 box. You go up and down, that's going to take us to magnesium. And then we have 3p, which has the 3 sublevels. And we're going to go aluminum, silicone, and phosphorus. And so this is showing us where something is going to bond. It's our outermost energy level, valence electrons. And this is the same exact thing as drawing it. We had 3 half shells, or suborbitals half full. Remember on the X, Y, and Z when we drew it? Right here. So we had 1 here, 1 here, 1 here. Same thing. We have 1 in here, 1 in here, 1 in here. Yep. And then if we do go to the D block or the F block, we do the same thing with the Aufbau diagram. It would be really big. We'd go 4s, 4s, and then we'd go to 3D,
And then 4p. Oh,
4s, 3D, D,
4p. Then 5s, 4d.
Okay, and you would just continue. So as long as it was an S, it would get 1 box. If it's a D, now we're going to get 5 boxes. And so if we did this, then we get 1, 1, 1, 1, 1. Oh, these would have to be full. Oops. And then 1 down for each box. And then you go up for the P. P gets 3 boxes.
Well, it's really simple to think about if you just think about it. We are just counting the number of electrons that each element has.